Hello, dear learners. When you are attending a math lesson with me, you get ready with a book, pen, and your calculator. In the last lesson, we were doing a full financial maths question from a question paper. We already did two questions already from grade 11 topic. The next question was about future value formula. In future value formula, what is important is the value of n. You must know how to find the value of n before we go through the problem. So let me explain how we find the correct number of payments using a timeline. A timeline means you represent the payments in a line starting from T0, T1, T2, etc. Let's say it goes all up to 2 years, that means 24 months. Now, if the question says the payment is starting 1 month after opening the account, that means it starts here at T1, goes all up to the last month. So then here n will be 24. Now the T1 also is different for different interest rate. If the interest rate says compounded monthly, then T1 says means 1 month. But if the question says quarterly, then T1 is 1 quarter, which means 1 quarter in a year is 3 months. So in that case, T1 means 3 months, T2 means after 6 months, like that. So you must be careful about that. Now, if the question says half yearly or semi-annually, then T1 means 6 months. T1 means 6 months then. Half year is 6 months. So T1 6 months, T2 will be 1 year, then T3 will be 1.5 year, like that. So that is another thing that you need to be noting down. Now let me draw another timeline where the payment x represents the equal payments in the formula. So here I am saying the payment starts immediately. It means it starts at T0, not after 1 month. Then continue to pay until the last month. Here in this case the n will be 1 more than 24, which is 25. Let us also take one more timeline with a different case. Let me say this timeline has T0, T1, T2, etc. up to T24, but here the payment stops at T23. Let's say the payment only starts at T1. Okay, it continues, goes all up to T23 only. How many payments are made? So if you think it's difficult to count or understand, you can also find the payments like this. N equal to, you take where the payments will stop, 23, minus where the payments started at 1 plus 1. So there are 23 payments. In this case, you can take the payment stopped at 24, but the payment started at T0 plus 1, which gives you 25. Here, the payment stopped at T24, started at 1, so plus 1. That the maximum value minus the minimum plus 1. That will give you 24. It is going to be helpful in other cases where they say it starts at T6 and it stops at 201. Then you can use that method to find the number of payments. So this is an important thing. I hope you have noted it down. Now let's go back to the examination questions that we were doing in the last class. Those who didn't watch the financial maths part 1, please go and watch financial maths part 1 also. Okay, let's go to the question now. Now we were doing question 8. Yeah, this is what we were doing in the last lesson. We stopped with the 8.3, no 8.2. Now we are going to do 8.3. Okay, let's see 8.3 now. 8.3, Thabo wanted to save 450,000 as a deposit to buy a house on 30 June 2018. He deposited a fixed amount of money at the end of every month. We already noted that end of every month tells you that it's an annuity formula. End of every month. That means X. There is an X. There is an equal payment. So that tells you that it's an annuity formula. So here he's saving and getting the money in future. So this is a future value formula. Now, so in a future value formula, all what you need is, we are finding, because the question says his first payment was made on 31 July 2013 and his 60th deposit was on 30 June 2018. Calculate the amount he deposited monthly. So you are actually not finding the future value, you are finding the monthly deposit, which is X. Okay, so this is the money he wants to save in future. So we are going to calculate how much he must pay every month to get the 450,000 after how many years. So that's the only challenging part here. Interest rate is given, the F you know, X you are finding, the N. So let's find the N in this case. From 2013 to 2018, how many years? 5 years. So 5 years monthly means 5 times 12, 60 months. Let's use a timeline to understand the problem. T0, T1, T2. The payment is for 5 years, so it's T60. Compounded monthly means every month is the payment. Now let's see whether the payment is starting at T0 or T60. He wanted to buy the house on 30 June 2018, and first deposit was made on 31st July 2013. So that means there is five years, but he didn't start paying on 30 June 2013, only on 31st July. 30 June 2013 is T0. 31st July 2013 is 31st July 2013 is T1. So the first payment was made on T1 now. Let's go to T1. So X is made at T1 and another X until the last payment. So here the N is therefore 60, because the first payment was made on 31st July 2013, not on 30 June 2013. So 31st July, that means T1, after 1 month. Okay. Now let's use the formula. So the formula here is F, future value formula, because he's going to get the money in future. 1 plus I to the power n minus 1, the whole divided by I. Now let's see, F we know it's 450,000. X is what you are going to find. You are finding the monthly payment. N we just now got 60, and I equal to I, very important. You must write it as it is. 8,35% compounded monthly. 8,35. So here we are going to say 8,35% divided by 12. So go back to the formula now. We are going to substitute. F is 450,000. 450,000 equal to x times 1 plus 8,35%. Don't forget to write the percentage sign. We are writing as it is because it's there in the calculator. To the power 60 minus 1. The whole divided by I again. 8,35% divided by 12. Now to calculate x, first step is to cross multiply. You cross multiply, that is 450,000 multiplied by 8,35% divided by 12. You cross multiplied. What will be remaining on the right hand side will be x times this big bracket. So if you divide by that bracket now, you only get x in one side. So this is the next step now. You are dividing by that bracket. 1 plus 8,35% divided by 12 to the power 60 minus 1. Yeah. So enter, use the fraction button in the calculator. Use the fraction button. Then you enter as it is. No change. Percentage you also there in the calculator. Put that percentage. Use the fraction button for I part. All the I part again use the fraction button. One step in the calculator. The final answer I have written the answer here for you. So you will get x equal to, final answer will be x equal to 6068,69. That is the monthly payment you are going to get. And now we are going to see 8.3.2. Tabo bought a house costing 1.5 million rands and used his savings as the deposit. He obtained a home loan for the balance of the purchase price at an interest of 12% per annum compounded monthly over 25 years. He made his first monthly installment of 11,058,85 rands towards a loan on 31 July 2018. So in this case, the problem is about obtaining a home loan and paying it back over 25 years. This means the sum of money is obtained at present. So you cannot use the same future value formula that you used in 8.3.1 because here he was depositing a fixed amount of money to get a sum in future. So that means here it's present value formula. Before we go to the problem, let me explain few things about the present value formula. The present value formula is P equal to x times 1 minus 1 plus I to the power negative n, the whole divided by I. Normally, we use the present value formula when you have a sum of money paid or received first and payments are made later. This includes all loans. Here you can see, okay, it's all loans. You must make notes on this one also. It is also used when a sum of money is kept aside in order to make regular withdrawals in future. That means, for example, someone retired and got a sum of money, but that person doesn't want to use the money now. So he put the money in the bank to get a withdrawal of, let's say, for example, 10,000 rand every month. So his money in the bank is getting finished over time. But the sum of money is now at present. So in that case also, we use present value formula. Loan payments are also like that. We get the money now, we used it to buy something, then we are paying off. So in these cases, we use present value formula. Now, while we are talking about the present value formula, there are these situations. For example, you took a loan let's say for 20 years to buy a house. You took a loan for 20 years, but after 5 years, you got a lotto and wants to settle the loan. Then you have to approach the bank and see what is the balance outstanding. Then the company will calculate and tell you the balance outstanding so that you can pay off the whole loan. So there is a formula for finding the balance outstanding, which is also very important here. So balance outstanding. Let me just write BO for now. Is always found by these two formulae, A minus F. A means we know the formula A 1 plus I to the power n minus F is the formula x times 1 plus I to the power n minus 1 divided by I. Now, if you're finding the balance outstanding, this is used when you're finding balance outstanding after n payments. So what the n here represents after how long are you finding the balance outstanding. So if when I said after 5 years and if the payments were monthly, that means the n in this case will be 60. 12 times 5, 60. So that 60 is used in the A formula and also in the F formula. This is how you find the balance outstanding. Now, also sometimes when you when the question will ask you to find the last payment, what is the final payment or the last payment you made? So let me also mention the last or final last payment. Let me also mention it together with the outstanding balance. So to find the final or last payment, you find the outstanding balance, multiply it by 1 month interest rate to the power 1. So I am not writing the 1 here. This simply means 1 month interest rate. This is how you find the last payment. So these are all your notes that you need to make before we use the B formula. Okay, I think now it's time to go back to the question. Let's see what is the question saying now. So I already read the question. It's about a home loan for 25 years and he's ready to pay monthly installment of 11,058,85 rands towards a loan. Okay. Now the question is, what will the balance outstanding on the loan be on 30 June 2039, 21 years after the loan was granted? So already given 21 years after the loan was granted. Actually the loan was for 25 years. Now he wants to know the balance outstanding. So we already got the formula. Balance outstanding is equal to balance outstanding equal to A minus F, which is okay. A is P times 1 plus I to the power n. What is the n in this case? You are finding the balance outstanding after 21 years and the interest rate was compounded monthly. That means 21 times 12, which will be 252. So this is going to be 252 minus the F formula x we are going to substitute later. Now let me write for now 1 plus I. I'm just showing you the n, how we found the n. Minus 1 divided by I. We are going to substitute now. But before that, what is a P? What is a present value? Now here the principal amount in the A formula, which is always a loan. But here there is something that you need to be careful here. He bought a house for 1.5 million and used his savings as the deposit. In the previous question, that was mentioned in the previous question as well. Thabo wanted to save 450,000 as a deposit to buy a house in 2018. So now he used that deposit. So the loan will be the remaining amount only, not the whole 1.5 million now, because he is having a deposit now. So let's calculate the loan amount. The P will be the loan amount. So let me write here for you now. The loan amount is going to be the 1.5 million, that is, yeah, minus the loan amount 450,000. Okay, so that will give you 1,050,000. So that is the loan. So when you are finding the balance outstanding, you use that is the loan, 1,050,000 times the interest rate was 12% compounded monthly for 21 years only, minus x is 11,058,85 times 1 plus 12% over 12 to the power 252 minus 1 the whole divided by 12% over 12. Now you can use it, maybe you can use this one alone in the calculator, answer minus this one, or I can also give it together in the calculator. So the final answer that I have written down here is 419,952,39. Check whether you are getting the same answer. Okay, so that is the answer for A. I hope you understand. If you have any questions, please comment in the comment box. Okay, A. Calculate the interest Tabo will have paid over the first 21 years of the loan. Calculate the interest Tabo will have paid over the first 21 years of the loan. So interest calculator, you must know how to calculate the interest. So in this case, it's little different because you are calculating interest after 21 years, not after the full term 25 years. So there will be a small difference, but we can still find the interest rate. Okay, this is a formula for finding it's 8 point, it's we have interest. You can write the question number there. Let me write the formula for now. Total repayments minus loan. That is a formula for finding the interest. What you paid and what was a loan amount. So the difference will be the interest paid. But in this case, in this case, the interest paid is going to be total repayments means you are paying 11,058,85 every month for 252 months, 21 times 12, minus what is a loan that you have paid. So it's not the loan is not 1,050,000 because you didn't pay it full. So because you didn't use the full 25 years, this is how you find the loan paid. That is 1,050,000 minus the outstanding balance. This is still remaining. This is the outstanding balance. So that will also be there. So this is how you find the interest paid in this case. So this is something that you need to note down. Okay, so this amount, this is the loan paid in this case. It's only because we are finding the interest paid in between, not after the full 25 years. So the final answer is going to be 21 56778 comma 52. That is the final answer. Okay, with that we are done with that question completely. So this is actually 8.3.2b. Even though it's written A here, it's B. So we are done with that question also. So we'll go to another question in the next class. If you have any questions, please put your questions in the comment box. And if you understand, you like, share and subscribe. Thank you very much.